friends. Forgot to turn my volume up. Welcome to this episode of the AI Show. We're on episode number 7. How is that for cool? My name is Seth Juarez, and we are here today because we are celebrating how cool AI is. Today we have a number of cool things going on, but I want to remind you that this show is all about your questions. So make sure you have them come on. If you're like, hey, I have a question about those beautiful drawings behind you. Yes, I did draw them all myself. This week, we've got one guest to talk all about running machine learning anywhere. It's pretty cool. And then after that, we have just a full 90 minutes of us coding together. We're going to be moving over some PyTorch code over to PyTorch Lightning. We started that last time. And so let's do this. I want to go ahead and get this ready because you recall that we have this lovely Wacom tablet. That we're going to be going over what we're doing today. And we're going to stick to it because I feel like we're not doing the projects fast enough. And like I said, we're going to be working on getting some of you folks to contribute as well. If you have any cool AI projects or frameworks you want to come on the show and talk about, I would love that. So welcome again to the AI Show. My name is Seth Juarez. I'll put this background music on here a little bit. And then we'll go to, we always like to go to the pen here to review what we're doing. Okay. So number one, just a reminder, we have Sauyra. machine learning anywhere. He has some really cool stuff. So I'm actually quite excited about that. And then number 2, and this is where I'm going to be a little bit more prescriptive here because I want folks to know exactly what we're doing today because I want to get some stuff done. Like I keep like half getting stuff done, but we're going to get stuff done today. And the way I like this to go is let's be interactive. So today we're going to convert standard PyTorch. Well, I'm going to say standard because it's like my garbage code that then we're going to fix and move over to PyTorch Lightning. We started this a little bit last time, but I just did not get far enough, and we're going to have room to breathe and get some of this stuff done. So number 1, let me do A because I already did numbers here. We're going to try to build a module for the model, if you will, using PyTorch Lightning. So we're gonna all read the docs together and then implement it. So we want to get this done, and then B, I want to see about the data story with PyTorch Lightning. What's the data story look like, and hopefully implement that, and then C, run the training. So we're going to try to get these 3 things done today with the coding bit, okay? And we're going to learn all this stuff together. So that's what we're going to be doing. But again, the first thing we're going to do is we're going to work with Sauyra here. So what I'm going to do now, let me bring him on. I think he's here. All right. Hey, Sauyra, are you there? Oh, I got to... Oh, he's there. Fantastic. How you doing, buddy?
Doing great. How are you?
Good. So as everybody knows, we actually record AI shows inside of the AI show live. So for those that are watching, you're basically here in the studio audience. So if we make mistakes, sorry, we will edit them out later. But you're watching like, this is how we record AI shows, but we just figured we'd stream it out live. And Sauyra is super nice, and he has agreed to stay on after to answer any questions that any of y'all might have. So that's the cool bit. All right, Sauyra. So for you and me, let's make sure we get your screen here, if possible, and then we'll get this sorted out. By the way, this music behind, what is this? I feel like I'm in an 80s video game. You know what I'm saying?
Yep. Super fun. Light background music.
Thank you. I was going to say that I made it myself, but that would be untrue. All right.
No,
so your screen, are we getting your screen up, bud?
Yes, I'm sharing my screen.
Love it.
Wasn't sure. I just wasn't sure if you wanted to chat and be a little bit, get a context to start with and then share the screen.
We will. I just want to make sure that I have your screen. That way I can switch to it super easy. Okay.
Cool.
Okay. That's there. So that's working. All right. And then let me get my stuff up over here. There you go. Okay. All right. So instructions for you, Sauyra. I'm going to do like a little intro bit, and then we're going to run our cool little video thing, this thing.
Okay.
I just give and then we'll jump in after that, okay?
Cool. Makes sense.
All right, it's time to pay the bills. And Vanessa, one of our main producers, is not here today. So Brenda is here. And so someone just knocked on my door too. I wonder what's going on over there. Brenda's watching, so we have to be on our best behavior today, Sauyra, unfortunately. All right, let me get this ready here. Banner number 2. And there you go. Okay, are you ready, Sauyra?
Yep, I am.
Did you say yes? Are you still talking?
Yes. Can you not hear me? What happened?
I stopped hearing you for a second.
Can you hear me now?
Nope, can't hear you. It's okay. We're running to your on mute issue. Let's see here. Let me mute you and unmute you, and then see if you're good. Yeah, looks like you're good. All right.
Can you hear me now?
Speak? No, I can't hear you. But
Very
what we
strange.
can do is I can literally like mime for you. So if you say stuff, I can. He's like, yeah, yes, Seth, yes, okay, okay. Yeah,
Okay.
you totally went mute on me, my friend.
Can you hear me now?
All right. Well, I'm gonna turn the background music on a little bit here, so we
Hear
can
me?
have at least some. No, I can't hear you. You might have to. You might have to come back. Like,
No
go out
problem.
and
Come
come
back. Yeah.
back. 'Cause I don't know what's going on. Oh, look, now he's gone. Hi. Well, you know what? This actually is a good spot because they wanted me to make like a video to they wanted me to make a video where I would like do like a hey, this is the AI show video. So let me see if I can do one of those real quick. Oh, he's joining. Here we go.
Can you hear me?
All right, can you hear it? No, I can't hear you, buddy. Something
Whoa.
must have happened to your audio thing. So let me do this. I'm going to make a video real quick because I'm supposed to, and then we'll come back. You keep looking around for your audio settings. Just make sure that your browser can accept audio. But I'm going to make this video here because they want me to make an evergreen video to get people excited about the AI show. So I'm going to do like 1 or 2 cuts, and y'all need to tell me which ones you like the most. Okay, which ones you like the most. So let's get going here. All right. So let me get this up here. All right. And I even have some cool music for it. Okay. So let's see if we can get this to work. All right. Here we go. Evergreen. Evergreen.
Can you hear me?
Join us for the AI show. In the show, we get to get folks. I don't like them. I'm gonna start again. That was a garbage one. Garbage one. Okay. Redo. Okay. Join us for the AI show. In the show, we get to get folks caught up on some of the latest innovations coming in AI on Azure. We also introduce folks to amazing AI frameworks, tools, and projects. And yes, we work on real-life machine learning code end to end. And really, we're just here to have an awesome time hanging out. Make sure you catch the AI show every other Friday on Learn TV or your favorite streaming platform. We'll see you then. All right, was that too cheesy? What do y'all think? Was that super cheesy? Kevin's like, lol. You didn't like that, Kevin? What do you think? Should we keep that? Should we do one more? I think we should do one more. Okay, let's do one more. But again, like when you're watching this, you got to be like, whoa, I would totally watch that show if I saw that promo. Kevin's like slight cheese. Yeah. I felt it. Thank you, Kevin. If it wasn't for Kevin Oliver here, we wouldn't. Someone's got to be here to keep us honest. Okay. All right. Let's do one more time. Okay. We got this. Okay. Hold on. Can we hear? Okay. All right. Can you talk now, Sauyra?
Can you hear me now?
Keep talking. I can't hear you now.
No. Wow. This is.
Like I literally just heard you a little bit. That's okay. You keep trying. I'm gonna still do the thing. And just keep trying to talk. But I'm gonna do the thing here. All right, here we go. Friday is the only day that has AI included in its name. Lakshmi. That should be part of the promo somehow. Yeah, I know. All right, let's do this again. Kevin's trying to keep us honest here. But by the way, can you speak now? Try again.
Can you hear me?
No, you have to switch. So you probably have to switch your mic settings, or so that one's not working. So I'm going to mute you for a second, and then we'll get you on. We'll get you back in a second. Okay. All right. Here we go. We're going to do this again. We're going to remove the cheese. I don't know how I'm going to do it, but we'll do it one more time. Okay.
Can you hear me now?
Here we go. Okay. Here we go. Here it is. Okay. Not less cheese. Okay. Join us for the AI show. In the show, we get folks caught up on some of the latest innovations coming in AI on Azure. We also introduce folks to amazing AI frameworks, tools, and projects. And yes, we work on real-life machine learning code end to end. And really, we're just here to have an awesome time hanging out. Make sure you catch the AI show every other Friday on Learn TV or your favorite streaming platform. All right. How was that one? Is that one better?
Good. Hear me?
Do you troll this guy when you say I don't hear you? No, I don't. Do you guys hear him? Is it just me? Maybe it's just me. Hold on. Try again.
Okay.
Yeah, I hear you. It was me. Oh my gosh. Everyone hears you except me. You know what I did? I'm such a goober. So listen, I'm going to turn this way so I can look at you, Sauyra, and just apologize. It was my bad. No, I have a soundboard. Everyone's like, are you trolling? Here, hold on. He's like, Dienos is like, are you trolling this guy when you say I don't hear you? No, I promise I wasn't. My soundboard volume was down on the computer one. My bad.
No worries. This is what happens when you have too many gadgets around, floating around.
Totally my fault. Look at. He's like, ah ha ha. Yes, laugh at me, please. Everyone's like, Seth, you goober. It's April 2nd.
April 2nd.
Oh my gosh, I'm so sorry. We can hear him fine. Everyone's like, yeah, we hear him. Even the channel 9 person was like, come on, Seth. All right. Good. Everyone can hear him. Everyone can hear him. Everyone can hear him. Why the host cannot hear? Johnny, the reason why I can't hear is because I'm a goofball, and for some reason I had my audio on the because I have a soundboard. That's why I can like turn stuff on and off like that. You see that? That was totally my bad. But it was funny, so we'll keep it. Thanks, Johnny. By the way, thank you. Kevin's like, Kevin, by the way, Kevin has said that the second one was better. So that's the one we're going to keep. They told me to make an evergreen promo. The marketing's like, hey, Seth, we need to make a promo for your stuff. And I'm like, okay. Sorry. So let's get your screen on here. We're not going to do your screen yet. So we'll go here. Thanks, Kevin. Second take was better, Seth. Thank you. Like, I love how Kevin's like, it was better. And I'm just like, I don't want it to be better, Kevin. I want it to be great. Thanks, Kevin, for your honesty. That's what we're here for. All right, Sauyra. Now we have to actually do the show. Are you ready?
Yep.
I got it this time. Okay, I got it. So you just look straight ahead and freeze for a second, because when I switch things over, I might not be able to push these buttons in the right order and fast enough. Are you ready?
Yep.
You're not going to want to miss this episode of the AI Show, where we talk about running Azure Machine Learning anywhere with Sauyra. Make sure you tune in. Hello, and welcome to this episode of the AI Show, where we have a special guest, Sauyra Das, to talk all about running Azure Machine Learning anywhere. Why don't we start with an introduction? Sauyra, why don't you introduce yourself, tell us who you are and what you do, my friend.
Sure. Hi, everyone. My name is Sauyra Das. I'm a product manager in the Azure Machine Learning team. I focus primarily on the hybrid strategy, and I do that through the integrations with Kubernetes.
Fantastic. So tell us a little bit about Azure Machine Learning for those that don't know.
So Azure Machine Learning is this Uber product from Azure that allows you to do everything machine learning. Now, machine learning is big. There's way more in machine learning. It's too huge. There's data preparation. There is training models using multitudes of frameworks that you have: PyTorch, TensorFlow, MPI, and then there is serving or inferencing. There is reinforcement learning. Then the space keeps evolving. So there are pipelines, MLOps. There are open source projects out there like MLflow and others, Airflow. So it's all that, and we have a suite of products that help you solve these problems.
So looking at the title, it says running Azure Machine Learning anywhere. I mean, are folks restricted to only cloud compute when we're doing things in Azure Machine Learning?
No, it's not just the cloud. The idea is to move beyond the cloud, so allow you to have a consistent experience in the cloud, and then anywhere you have Kubernetes clusters. So standardizing on Kubernetes, which allows you to extend anywhere. like I said, just includes AKS, GKE, AWS's container services in the cloud, and then you've got the on-prem solutions like you could have Azure Stack Hub or Azure Stack Edge, or you could have any Kubernetes cluster on the on-prem, which you bring to Azure through Azure Arc for Kubernetes. So I can give a bit about Azure Arc for Kubernetes if you want.
So I think you're going super fast because I think you said that you can run Azure machine learning jobs on GKE, Amazon, and even on. Did I hear this right?
Yes, that is correct.
How is that even possible? I know you said Arc, but can you explain what Arc is and how this makes it possible?
Yep. So Azure Arc is this umbrella project, and that has a specific line of product called Azure Arc enabled Kubernetes. And what that allows us to do is, you have Kubernetes clusters, like I said, across cloud and on-prem. You install Kubernetes, and then you install the Azure Arc connected bits. And what that allows us to do is give it a Azure Resource Manager ID, and allows us to track these on-prem clusters or other cloud clusters in a single pane of glass, as I will show you in the Azure portal, centrally govern them, manage them, apply policies, monitor. You can also, see security hassles and all that. Everything is included.
Well, this is awesome. I feel like we need to take a look. Can we do that?
Yep, sure.
All right, let's pause right here because it looks like you're not sharing your screen right now.
Okay, sharing my screen. See my screen?
Oh, yeah, I sure can. So what I want you to do is I'm going to add it to stream. And what I'm going to do is I'm just start off by saying, so what you see here, and then we'll go from there, okay?
Okay.
All right, go.
So what you see here is the Azure portal, and I have customized the Azure portal to show me.
Let's pause right there. Let's do it again. Let's just hit hide on where it says sharing or stop sharing. Just hit hide right there. That way we don't have it. All right, so let's start again. Just like, so what you see here?
So what you see here is the Azure portal. I've customized this to show me resource groups, machine learning, and Kubernetes services. But you can customize this to show anything. So let's go to Kubernetes services because that's the most relevant part here. As you can see, this UI shows me all types of Kubernetes assets that I have. If I go and group them by type, I will see two types of Kubernetes clusters. One is Kubernetes service. This is Azure's managed service, Azure Kubernetes service. I've got two clusters in the cloud. The other is Kubernetes Azure Arc. This is Azure Arc enabled Kubernetes. These are clusters that are elsewhere, and we brought them to Azure by giving them a Azure ID or an Arc resource ID. And this includes AKS engine clusters. There are NVIDIA Arc clusters. There's a GKE cluster. And there is my desktop. So I installed Docker Kubernetes on my engine, on my laptop, and I brought it to Azure. All of these are Arc bits. Go ahead.
So let's pause right here. So basically the two Kubernetes at the bottom are just standard, AKS, Azure Kubernetes services. The ones above represent Kubernetes services that are running outside of the context of Azure, including one that's running on your laptop. Is that right?
Yep. So a couple of them are AKS engine clusters. So I spun up VMs on Azure and I deployed Kubernetes on them.
I see. So it's like a homegrown, like you made your own, you spun up 3 VMs and did a Kubernetes cluster.
Yep.
Fantastic. So now that these are here, how does one access them? Because look, as a machine learning guy, I like hardware. I just don't like messing around with it. Do you know what I'm saying? How does a machine learning person access these clusters to do training? Do they have to know anything about Kubernetes?
They don't have to know anything about Kubernetes. We have built the persona such that the IT operators in organizations can set up these clusters for their data scientists, and data scientists just need to know their targets. So I can show that bit. So what you see on my screen is the Azure Studio, the machine learning studio. And this is primarily the place where data scientists, one or more data scientists come in. They keep all their assets here, including experiments, models, data sets, pipelines, and whatnot. They keep everything here. They do their training jobs here or serving and whatnot. This is the centralized place for all their assets. Now, what they can do is, I just showed, the IT operator goes in, creates these clusters, sets up these targets they enable the Azure Arc bits on the cluster. They enable Azure Machine Learning. I will just switch over to my CLI, and I have a cluster. So let me show you what this cluster is. So let me just clear the screen and do. This is a 3-node cluster. This is a 3-node cluster that I have, Azure Arc cluster. And then what I have deployed on this is going to be important. So you can see that to bring this cluster to that view that I had, you have to install Azure Arc bits. So this installs a bunch of bits and make sure we can see it in Azure and centrally govern it. Then the second part is installing Azure Machine Learning bits. This will allow you to use this cluster to deploy training jobs onto this specific cluster. So you will see that in the specific namespace Azure ML, you've got a bunch of operators or operators deployed. So you will see that we have some MPI, PyTorch, TensorFlow operators. Then we've got an Azure ML operator. We've got job exporters. Of course, we use metrics to report back to Azure, so we can show them to you in a centralized location. But this is what a cluster looks like once an IT admin sets it up for the data scientist team. Now, data scientists can go to the Azure Machine Learning Studio.
So let's pause right there. So all of that stuff happens by someone that's a Kubernetes person. Because if you're running these things on your own Kubernetes cluster, ostensibly, probably you have somebody that's literally running that stuff. But now to actually get that running, you don't have to do anything. You just have to cook it up. Can you show that to us?
Yep. So in the Azure Machine Learning Studio, you have the compute tab. When you go to the compute tab, we have two sets of compute. One is all of this is managed compute. These are compute that you just use to, just pay per use, and you don't care about using, updating the infrastructure and all that, security patches and all that. The other part is the attached compute, and that's where we've integrated Kubernetes. You will note that it says Kubernetes service. This is a simple pane where you come in and give it a name, say my target, and then you choose a Kubernetes cluster. So this Machine Learning Studio is in the same subscription as my portal. So you will see all the exact same clusters here. Like I had 2 AKS clusters and I had 6 Arc clusters. You will see all of them. And you can probably select any of them as a target and say attach. I already have one attached for you. It takes a couple of minutes to attach, and you're all set. These are all the targets that are for a data scientist, and you can target any of these for running your training jobs. Now, this step could also be done by the IT operator, but it's up to you. And we have provisions where you can select an entire cluster and target the default namespace, or you can provide a specific namespace that will allow you to deploy to that namespace. Typically, in IT, in big orgs, IT operators split their large clusters into namespaces and hand them out to data scientist teams and dev teams. So you can do that as well.
That's interesting. So effectively, if someone has on-premises Kubernetes clusters that already have GPUs, that already do all the thing machine learning folks want, but you want to take advantage of Azure Machine Learning for, let's just say, it's dashboards and logging, you can do that now.
Yep. Use the excess capacity anywhere you want on the fly.
That's awesome, man. Because some people are afraid to move to the cloud because they're like, well, we already have a bunch of clusters. But Azure Machine Learning is actually really, really good at the exhaust of machine learning, like logging and everything. And now you can use actually both. So where can people go to find out more, unless you have something else to show us?
Yeah, I have a demo of showing how you quickly, the data scientist should not have to make a whole lot of changes to run a notebook. So what typically a data scientist does on a day-to-day basis is, they have sample notebooks. This is an image classification traditional example. I've got this notebook. I wanted to call out that, there are a bunch of steps here. You import a bunch of packages, Python packages. You install the Azure SDK. You connect to this, what is called as a workspace or a project. This view is a workspace where you keep all your assets. Then you connect to this workspace. You create a sample experiment. And this is the only change as a data scientist you got to do. You got to import this package, and you give it one of the compute targets that you set here. That's it. And then you are just all set to use AML just like you were using before. So we want you to be productive. We don't want you to be wasting time learning Kubernetes or anything. So everything has been all set for you. You can run through the entire script all by yourself. Nothing changes. And I will just submit sample job and show you how it works. So this is the last step of submitting a job. After you set a compute target, I will run it. And then I will go to the experiments tab. This is the entire experiment, image classification experiment. I will show you that, these are all the jobs that have run on this cluster. This is, this is the one that I just submitted, has been queued. It will run. And so, yeah, this is, you click on any experiment you want. You can familiar, view of the properties of the run that you have, the metrics, the images that are being used, the child runs or the output logs. The output logs tell you what is going on when you submit a job. You can track it. So you can see that it's now starting a pod. So yeah, nothing from a data scientist perspective, nothing changes. You can see it's already gone into running stage, and it will complete right now. So let's go ahead and take a look. And the IT operator can go back to the CLI, their favorite tool, and take a look at if everything is working fine, the cluster has not been destroyed in any format, so they can do get jobs, and they will see that this job was scheduled 59 seconds back. It's all good. They can look at the logs. They can using the kubectl command line, they can look at the logs, describe and see what the events are. They can they are basically allowed to slice and dice the cluster just the way they want. So there's also a corresponding pod that's also been spun up and is running. It will run to completion, and you will have your run. So one of the things that I want to point out is this compute target. You can very quickly change this compute target in your notebook and target any cluster. It could be any cluster on-prem or in the cloud, as set by you in the target. So yeah,
that's really cool. So basically, all you have to do is change the compute target, and you're done.
Yep, right here. That's all you need to do, and you're all
well. This is awesome. Where can people go to find out more?
So there is a link to a blog that we wrote. So we are in gated public preview. So sign up sheet is there. You go sign up, and we are slowly onboarding customers to try this out.
Awesome. Well, this has been amazing. We've been learning all about how to use on-premises Azure Machine Learning clusters using Azure Arc. Thanks so much for watching, and we'll see you next time. Take care. All right, so listen, Sauyra, someone brought up something, and maybe we should look at this. Johnny Tien said, "Please zoom in 20%." So we can either keep what we have, or you can zoom in a little bit more.
I can zoom in. Yeah, zoom in like this. Yeah, I can zoom in.
Let's see here, because we'd have to do the whole demo over again. Is that something you want to do?
Yeah, sure. Why not? What is the point in having something that doesn't show things?
And Johnny, thank you for telling us that, by the way. Awesome. But I just caught at the end. I was like, is this small for me, or is it just that I'm not full screen? Did anyone else have a hard time seeing the screen? Let us know. By the way, let's do this. Let's take some questions for Sauyra first. And then if someone wants us to if folks want us to redo the demo so that you can see a little better, let us know, and we'll do it over. Johnny for sure does. If there's any other votes, we'll do it. So here's a question from Kevin. Do the Kubernetes clusters show up in the compute instance list or attached compute tabs in the workspace?
They only show up in the attached compute tabs, because that is where all the attached compute clusters that you bring to Azure Machine Learning are listed. Compute instance is a managed instance that only shows up in the compute instance.
Got it. So what you're saying is that it'll show up, but it'll show in the attached compute, correct?
Yes.
Fantastic. Here's a couple of other questions I saw, and maybe I should have asked this, but I'm just thinking of it right now. There was a ton of nodes, or I don't know what they're called. Look, I had to do Kubernetes thing one time, and I did not know I had 28 hours in a day to figure stuff out, because it's like diving in the deep end of the pool with spikes and stuff. So those things they're the pods that we're running. I think they're called pods.
Pods.
Those pods, are they set up when you set up Azure Arc?
Yeah, so there are multiple pods that I shared, right? There were some in the kube system namespace. Those are required for the Kubernetes cluster to function properly. They come up when Kubernetes comes up. Azure Arc, there was a namespace called Azure Arc, and there were pods deployed there. That is how you bring a Kubernetes cluster to Azure through Azure Arc for Kubernetes. Then there were pods in the Azure ML namespace, and those are the bits that are set up in the cluster. These pods are set up so Azure Machine Learning can deploy to the cluster.
I see. And so when we attach the Kubernetes cluster, those already need to be in there, and then the admin of the Kubernetes cluster does. I see. That makes sense. And what's cool is that if you have a Kubernetes cluster with like 50 bajillion nodes, all you have to do is set up the right pods, set up the right namespacing, and then all of a sudden, as a computer science or as a data scientist, you can have someone go in there and attach those as attached compute. Is that right?
Yep, they can compute and deploy training jobs to those targets.
Okay, so let me see what my folks are telling me. If it was too small here, yeah, everyone can hear him. Everyone's like, Seth, we hear him. It's just you. Yeah, I figured it out. So sorry. All right, so we'll keep it. I think it looked pretty good, and the concepts were good. Johnny, if you want, ping me, and we can give you a demo with stuff zoomed in if you want. I mean, happy to do that as well. But what do you think, Saudi? Should we re-record it, or are you good?
Up to you. Just let me know.
I think we're good. For now. But Johnny, thanks for bringing that up. I saw your comment. I'm like, should I have him stop and we should start over again? But I figured we'd just get that take and then go with. All right, buddy. This has been awesome. Again, so sorry I messed up on the sound.
No worries. Thank you.
It was funny though, a little bit, at least in hindsight, right?
Oh yeah.
April Fools +1. Yay. Hold on, let me do this again. April Fools +1. Yay! All right, dude, you're the best. Thanks for coming on. We'll see you next time.
Thank you for the opportunity. Bye.
All right, bud. Cheers. All righty. Now it's just us, so I can turn this music back on here. All right. Let me add my stuff back here. Let me close all the things that I'm not using anymore. Boop. Okay, so now let's get into the work. I promised we would do some work now, and here we are, getting ready to do the work. And I wish, because my screen is like here, and it looks like I'm looking away. I should reverse myself and do this, right? So when I'm looking at it, it's like, see, look at all this wonderful code, But here we are. All right, so now what we're going to do is we're going to actually write some code. And what I want you to do, and I'm going to be very cognizant of this, you stop me or ask questions as we go. And like I said, I'm monitoring all the chat on Twitter, on YouTube, on Learn TV over here. In fact, if something comes on Learn TV, you'll hear like a little beep boop. Yeah, even Peggy. Oh, okay, cool. Was telling me that we can hear him. But yeah, so I want to hear your questions because I might start going too fast, and we don't want that. And this is like we're live coding some machine learning stuff. And what we're doing is we're converting this garbage code into PyTorch Lightning. In fact, I think I started some of the work last time. Let's see. Taking a little sip here. Yeah, see, I started trying to do that. I don't know if I like this. I don't think it's right. So what I'm going to do is I'm going to do the old school, old. And let's just move stuff over. Except for this, of course. Let's move stuff over. Okay. So, gone. Be gone. Old code. Be gone. Let me save this file here real quick. Okay. Okay, so now we have all of this code, and just as a reminder, what it does is, let's see, let's just ls cd src src ls. Dang it, I shouldn't have moved it. Let me put it all back so you can see what it does, and then we can go into the refactor. Okay. Okay, so we'll do PyTorch, Python train, and you'll see that basically what this is doing, hopefully I have enough memory. Last time this was throwing a bunch of errors because my hard drive was running out of space. It's a real problem. Also notice that we changed from a ResNet 50 to a ResNet 18. Here you go. Right, and look at the speed of this. Look at this beautiful bean footage. That's an old school commercial, by the way. Notice that we're building models, and notice we went from garbage training accuracy to good, better, and you can see that this is actually going a little bit faster. Now, I think I don't know how many epochs. How many epochs do we have this going for? 25. What are we gonna do? Just stare at each other for 25 epochs? I think we should. By the way, notice the accuracy is getting really good. And these numbers are not too far away from each other, which is not bad. This may be a little concerning. So we're definitely not an overfitting problem with the ResNet 18. These numbers are not improving, though. Do you see that? And also I have learning rate back off going on here. Yeah, so this is kind of concerning that they're that far apart. Oh, but see, I don't know. It's just maybe the way things are being split out. But we're already getting 96% accuracy on the validation. We're at 86 on the training set. We have 281 batches. So that's what we're doing. We're building a rock, paper, scissors thing. I showed you in the very first show how we could do this in using custom vision. But here's the pictures, right? Me doing nothing. Me making papers. Me making rocks. And then obviously the scissors. And so that's what this is doing. This is basically taking these pictures and running them through this sequential model that we're gonna make all this code not so garbagey. I feel like it's super garbagey. If you want to know like where it is, by the way, it's github.com. GitHub.com AI advocates. And then you should see Roshambo right up in her. And this is all the code, right? So this is what you're seeing me doing. So if you're like, I want to go see what he's doing, you can see all of that here. I try to be super, super clever. And I feel like when you try to be super clever in code, you're only just hurting yourself. Right, we're on epoch 19, which is pretty good. Notice that we're starting to plateau a little bit, and that's because we're doing learning rate back off. You can see that right here. Our learning rate now is at 1 times 10 to the minus 5. We started out on 0.01 10 to the minus 2, and then you can see that every 7 or so epochs we add a decimal. That way we slow it down a little bit. This one's really good because these ones are. These all seem to be like 10 points away from each other. So basically what I do is I save every single model, and you can see that right here. Right, I save every single one of them. And then I also save the very best one. And then the model meta, you remember, is a way to save classes. The classes in the thing. And then finally, if you look at the scoring, right, you can see that this basically just scores it. So if I were to do this, and just a reminder, I need to make it so that I can see these pictures. So let's go to CD Rochambo ls cd data ls cd eval ls. You can see there's a rock and a paper. So I'll do Python -m HTTP server. Kapoop. There you can see now I can localhost these things. So if I go over here. CD Rochambo ls, oops, ls, yep, CD source, Python score. Oh, no. I'm going too fast. Python score.py. Oh, Conda, activate. Torch to be in the right environment. By the way, you can see my Conda environments. I see what they are all the time. So there they are. So Python score, boop. Can you add the link to the GitHub repo in the chat? I sure can. Notice here that it's doing inference with rock, and it guessed rock with almost certain accuracy. You can see here it guessed paper with almost certain accuracy. And by the way, this is the model that it's still training. It looks like it finished. But it's using the best model that it found in terms of validation accuracy. And you can see it here. It's looking for the model path as in dot dot outputs. So that's here. And then what it does is you can see that it opens the metadata file that tells us the classes. And then we set up an inference session with the Onyx model using the Onyx runtime. All right, what are people telling me here? I want to make sure I see what people are telling me. Oh, they can hear Saudia. Okay. Okay, cool. Then we have some transforms, and then whenever we run this, I basically pull the image URL, I get the bytes, and then I do the magic of running the session, and then I output the thing, and that's what this is what this is doing, right? So you're seeing that it's actually working, but I don't like this code because, like I was trying to tell you, it feels a little all over the place, and my programmer brain is like, I don't want to do that. So we're going to fix it by using PyTorch Lightning. So that's what we're doing. So let me see if I can put this link in the chats. There, I try to put them everywhere. Some of them won't let me put links in there, but that's okay. So you should see it on, if you're watching on Twitch, you'll see it. If you're watching on YouTube, you'll also see it there, the link. Okay, so now that I've done that intro, now we have like an hour and 15 minutes, which is exactly what I was hoping for, to redo all of this in a nicer way. Right? So let's do this here. Let's do new file, and I don't know. We're going to do the model first. Model.py. And we started over here, you recall, in our notebooks, in our refactor. Let's go open in the notebook editor. We started trying to do this Roshambo thing, but I think this is wrong. So let's go to, let's open up a new one of these doohickeys, and let's go to PyTorch Lightning. Boom. I feel like I should have a lightning, a lightning. I already installed it, by the way, so I think it's in there already. So let's go to the docs. And let's see, here, Lightning module. Minimal example. Yeah. Here. Okay. So the thing about this is that they keep saying that it's literally the same as a Torch module. So for those that don't know what a Torch module is, pytorch.org. Let's go to tutorials here. Learn the basics. Let's go to build model. Here you go. So notice that defining a module, we subclass module, and this is basically like a standard PyTorch thing. And if we go over here, notice that it has the same two things, right? But I think what they've done is they've added some goodness, to make it a little easier. Because notice that I try to be clever. By the way, this is why I'm telling you why I decided to move it over. Notice that I have some training. This is basically train a batch, and this is basically train an epoch. And notice that I'm doing like the same things, like have a train thing. And I just don't want to. I don't want to do that. I'd rather just have it all in like one place. So that's why I'm moving it over. So it's just clearer to understand. By the way, please ask questions, because like I said, all of a sudden I started going really fast because I really want to get stuff done today. The other times I feel like I'm shortchanging my peeps, which are you. So we have model here. So let's do this. Every self-respecting programmer, right, basically does stuff like this. And you're like, what the heck, Seth? This feels wrong to me. It is wrong. So what we're going to do is, I know there's like a, I wonder if it's shift down. No, control Z. There is a way to, there we go. Control Alt lets me do multiple ones of these. There you go. Import torch. Doop. Okay, and let's do this. Doop, doop, doop. Just to make sure. This goes right here. This feels like it goes right here. This feels like it goes right here. This feels like it goes right here. Boop. Let's see here. So it looks like we need to do some import torch torch dot nn as nn. We fix that. Looks like we have the F thing. Import torch dot functional as F. Now we're good to go there. Look at that. So now we have this thing, right? Whereas before we had this thing, right? This is the model we want to build here. Okay. So notice that what we need to do is we need to reconstruct this, but the reality is that if you look at this, and this is the part that's important, is that these are the things that need to be saved, right? As part of the class structure. These are the things that need to be run during the forward, right? The softmax is there to make it pretty. So what we're going to do is when we initialize this, we are going to have a, looks like we need a models. So let's go up here, models, from Torch Vision, import models. Okay. Okay. And I always like these things to line up. So it looks like what we need to do is let's get this out of the way. Self dot, we'll call this the X for layer equals models dot resnet. Looks like our resnet 18 is just as good. So we'll do models dot resnet 18, and then we'll set the pre-trained equal to true. Boop. And then looks like we have a fully connected layer. So self dot fc1 equals models dot not models nn dot linear, boop, and then looks like 1000 by 256. And the reason why I know that basically the output of the ResNet is 1000, by the way. And yeah, thank you, Microsoft developer. We have here the learn the basics. Okay, and then we have so we don't need this. We don't need this. So self dot fully connected 2 equals nn dot linear, and we want to go 256 to how many classes there are. Classes, right? So I think we need to pass in class count, and then what I'll do is I will say class cont int equals 2 as the default. No, this is wrong. It needs to be right here. Sorry, comma. There it is. Okay, so that way we can pass in the class count, because that was the only thing. Or maybe I should give it the actual classes. Let's just do this for now to make this thing as dumb as possible. Okay, now what we're going to do is when we run the forward, this is what I'm going to do. We're going to say x equals self.xfer self.x for x, but we need to do the ReLU over it. So we'll do f.rel. I think it's, oh geez, no ReLU. ReLU. Let's go over here to remind ourselves. Yeah, torch.ReLU. What? Okay, maybe this is the right way. Torch.ReLU. Okay. I feel like this is, let me go to definition here. Broadcast tensors. The thing about Python, I used to be a C# guy. There are 3 classes though. Why choose 2? Says Kevin. I just did it for defaulting so that it forces me to pass this in, right? Because then it'll do the wrong thing for my stuff. So this forces it pass in. So I chose 2 as a default, even though I know for us it's actually 4. Here, let me show you. Here, let me put your thing up here. So let's go over here. You'll see there's actually four of them. Here, 4. But I just put 2 in, because I mean, for kicks and giggles, right? I feel like it's f.relu, but I might be wrong. F.relu here, and then we're going to say x equals f.relu. Oh, maybe it's right there. I don't know why. Hold on. Let me see. Let me see how they do it. Yeah, they do it like this. I don't know if I like that. Let's look at some other code. Import torch.functional as f. Oh, it's torch.nn.functional. Oh, that's why. Torch.nn.functional. Thank you. There you go. Now it's happy. Do you see that? I don't know if this is happy. We'll figure this out. We'll figure it out. This is still their old code. So f.relu. Come on. f.relu. And what we're going to do. Why is this in there twice? f.relu. And then we're going to say, why is there so many? That's what's going on. There you go. Everything's weird. We're going to do self.fc1 of x, right? And then what we can do now is we can softmax return the output. So return f.softmax of the self.fc2 of x along dimension 1. Whoop. Okay. So now what you're seeing is, let me get this out of the way, is ignore this bit right now. We're still not looking at this. So in theory, this is stupid. So let me do classes. And then let's keep this around for classes equals classes. By the way, this is object-oriented programming for Python if you haven't seen this before. So hopefully I answered your question, Kevin. Yeah, I know there's actually 4, but I want to make sure that this is passed in right, so I don't. Right. So it's kind of like it's like a way of doing like a fake unit test where you put the thing that here, I could even put 0, right, to make sure. Or maybe I don't put anything. I don't know. Maybe I go like this. There you go. That for sure would make it break. And then what we're going to do is we're going to say Roshambo. Nope. Roshambo model. And then what we're going to do is we're going to use this doohickey to make sure that it all works. Okay. Okay, this looks nice. Life is good, right? And this looks exactly like this, right? So we have the things that we store, the transfer learning bit, the linear bit, 1,000 to 2. So if you're looking at this, you're like, I have no idea what the heck Seth is talking about. Think of a picture, right, as this thing, and then think of it as like this little thing right here is like a funnel that puts all the picture bits into it. And then at the end, there's a vector of size 4 that comes out that tells us none, rock, paper, and scissors. And that's what's coming out. So you notice that here, this number will be 4. Here, this will take in an image of a very specific size, right? Because we have those transformations. And then what it'll do is it'll run the ResNet model over them. It'll run a linear model over the 1,000 nodes that come out of ResNet, scrunch them down to 256, and then from 256 scrunch them down to the number of classes. That's what's happening. And the way that it does that is through the forward function. So if you give it the x, right, it's basically going to run the transfer learning over the x, run the ReLU over it, put it to x, then do this again, and then softmax at the end. So these two things are actually equivalent, right? But I think it looks. Doesn't it look nicer? Like I'm already feeling better about this. Because when this becomes like the biggest sensation since TikTok. Then we want to make sure our code looks great, right? So there you go. There's that. So now let's look at the training step. For us, looks like this is a batch training step. So let's see here what they say about that. Okay. So it looks like they're like, just run the thing. So it looks like it's just run the thing and get the loss out. And if you look at this, basically that's kind of what we're doing here and here and here. But it looks like they're doing they're eliding all of this other stuff. Which is fine. I mean, because this is exactly what I want to get rid of. So let's do this. Yeah, this is literally exactly the same, right? Because our cost function is, let's see what our cost function is. Yeah, cross entropy. Literally, this is it. We don't even have to change this. And notice that you're looking at this as self. We're like, why is it this? Because remember that this thing is basically a subclass of the standard, and let's see if I'm understanding this right, of the standard neural network module, right? Because you remember this NN module, we subclass this to make this. They've basically subclassed module to have lightning module. And so these things are literally the same. And so when you're doing self, you're doing self over the model. Okay, this is what we're guessing. And then cross entropy y hat y, blah, blah, blah. Now let's take a look at the configure optimizers. What is that supposed to do? Maybe they explain. Okay, init, used for inference only, separate full training loop. Define optimizers and LR schedulers. Oh, so we can do both of them there. Okay, so let's see if we can. Maybe they have a configure LR scheduler. So there's this. Okay. Inference and research. I'm looking for. Looks like they have callbacks too, because remember we kept saving our models, so we should probably look at that. Configure optimizers. Okay. List or tuple. List of optimizers. Two lists. The first list has multiple optimizers. The second list has LR schedulers. Okay. Okay, here we go. I see. So basically you return two things, a tuple. The first is the optimizer and the second is the scheduler. So let's do that. Let's see if we can do that. No, so what we'll do is our optimizer is the SGD optimizer. And let's do this. Let's pass the learning rate in. LR float. By the way, this is the way to like type annotate Python so that you can so when it's better for autocomplete. Johnny is telling us I did the same project as before, but used KNN in TensorFlow JS. Wondering which way is better. Great question. I don't know. Whichever one makes you happier, I guess. Okay. By the way, I don't know if there's very many live streams that like literally get into writing machine learning code. I'm just going to take a sip of my drink here as we enjoy that. By the way, please, if you're looking at this and you're like, what the heck is he doing? Please ask a question. If you have a question, of all the millions of people watching this right now, I may be overcounting. Of all the millions of people watching this right now, they probably have the same question as you. Literally put it in the chat. Put it in the chat. There should be more. There should be more what? I wonder what. More? Tell me more. Janny Skew, number 7. 7 is an interesting number, by the way. Okay. So we want the optimizer to be this. Oh, I forgot. I need to do self.lr equals lr. Oh, more ML streamers. Yeah, there should be. Like, I feel like machine learning people are either too busy or there's like a secret brotherhood, sisterhood where it's like, don't let anybody in. Adir is like, I want to see you submit this on a multi-node distributed training on Azure Machine Learning. Yes, I do. I do too. But I feel like that's in like in a week or a couple of shows. I want to get this. Running locally, and then eventually, like in a couple of months, once we talk to, I'm going to try to get our lawyer on because I want people to play this game online and submit their own pictures for training so that we can see the full ML ops pipeline. Like end to end, like I want people to. I even bought Roshambo.ai. It doesn't work right now because we didn't set it up right. But I bought Roshambo.ai so people can like go in there, make an account, and play against the computer, and then hopefully eventually play against each other. Right? 1, 2, 3, boop. Right, and then that's what I want to do eventually. And the reason why I'm doing this is because I think we do not have enough people showing like machine learning for realsies. Everyone's like, oh, we use AI. They're not. Most people that like I've talked to people that I'm like, hey, you know what you call AI is basically a where clause in a SQL query. But this is actual real machine learning, right? So thank you. Hideki, thank you. I love Japan. I have not been to Japan in a couple years, and I think this is Japanese, by the way. Correct me if I'm wrong. Hideki AI. But yes. Here's another. Just a few hours ago, I submitted a talk for the virtual ML.NET event next month. It's about rock, paper, scissors. What are the odds, Luis? I think we may be related. Yeah. We're related for sure. By the way, keep these things coming. I like talking to y'all. That's what this is for. And we have another, by the way, we've just reached the top of the second hour. Usually we have a guest on for something else, but this time we're going to get some more work done. Because again, I said I wanted to get the model and the data and training all in PyTorch Lightning. All right, so let's get the optimizer. Yes, Japanese. Fantastic. My brother lived in Japan for 2 years in Okinawa. And I just love it over there. Oh, such a beautiful country, beautiful people. No kidding. I was in a quote unquote dark alley walking home to my hotel from somewhere. So clean. You know, like if you're walking in a back alley somewhere in the United States, it's dirty. But even Japanese back alleys are wonderfully clean. So I slept in a dumpster. Just kidding. Not true. Okay. So let's get this Optim stuff up in her. So, boop. And there's something wrong with me. Oh, well, I don't want to do this. I don't need that. Okay. Okay, so far, so good. Okay, so now the optimizer self. Oh, did we do self.lr? Yeah, so we can do self.lr. Self.lr. And now here we can just say, because remember, this is the thing. So that's the optimizer. And let's take a look at our, so notice that the first thing was our optimizer, right? I think that's what, and now we can do our scheduler. Remember how we did, oh, we might do cosine. Wow, this is cool. We should learn about this stuff next time. Wow, exponential. I think I was doing I think I was doing something like this. So let's take a look at what we were doing for our back off. That way we can pass a scheduler. LR back off. We were doing step LR here. And LR scheduler comes from the Optim. So I can say scheduler, not LR. What? I don't need to do that. I don't want to do that. I'm going to say Optim.lr scheduler. And what we're going to do is we're just going to set it up the same way we did before. Step LR. Step LR. We might consider, scheduler equals. We might consider doing other schedulers. LR, oh no, LR scheduler, step LR. Very nice. And the optimizer, obvi, is this optimizer. And the step size is 5, is what we did. Step size equals 5. What else did we do over here? Gamma is at 0.1. I don't know what the gamma is. I'll have to look that up. Equals 0.1. And so now we can return the scheduler. Look at that. I mean, doesn't this feels better to me than all of whatever this going on over here. So much going. This is all like in a nice place. I feel like I can look at it. Like if my mom was going to be like, Seth, is this kind of like the question that your mom asks you, are you wearing clean underwear? You know, your mom used to ask you, are you wearing clean underwear? I'm like, why? Because what if you get in an accident and someone sees your clean underwear or your dirty underwear? And I'm like, well, if I got in an accident, part of that accident would be my dirty underwear. Wow, that music was super ominous for that joke. Thank you. Thank you. Okay, so I think this is right. Let's take a look at, let's see what we got over here on the module. This is a configure optimizers. Notice that they return the optimizer. The scheduler, yeah, see the scheduler passes in the optimizer. They're using Atom here. Maybe I should train with Atom, but I think I did it one time and it just didn't work. Right now I'm using stochastic gradient descent. You can see that right here. SGD. Okay. Yeah, I think this is it. Right? I feel like this is it. Okay, now we got to find a way to get the data in there, right? Let's do this. Let's do a model equals Roshambo model. And we're going to pass in classes of 4, learning rate of 0.01. Boop. And let's just see what we got. And then I'll just say x equals 2. I guess I can set a breakpoint here and make sure it's all hunky-dory. F5. Here we go. It's happening. Oh. Importing NumPy C extensions has failed. What the heck? I know this happened to me before. How did I fix this? You may go away. Let me make sure I'm in the right Conda environment here first. I'm not. Derf. Okay. Now we can F5 and see if that fixes it. Okay, here we go. So there's the thing. Looks like everything's in there. Looks like, wow, it says the device is the CPU. That's okay. There's my linear one, linear layer. There's my second linear layer. By the way, these things are all affine transformations if it weren't for the activation functions. Just FYI. This is not an affine. This is an affine transformation. This is an affine transformation. They're all just linear things. The thing that makes it work is these activation functions and calculus. Okay, so I think we're good. It looks like it's the right thing. Now we need to figure out the whole data thing, the data sitch. So let me go over here and let me go new file and let's do data.py. Okay. I think we're good. Let's just do that. Oh, LBFGS. I remember reading about that in school. Let's remind ourselves. LBFGS. Ah, yes. Yes. Is an optimization in a family of quasi-Newton methods that approximates the Broyden-Fletcher-Goldfarb-Shannon algorithm, BFGS, using a limited amount of computer memory. Okay. So this thing, the Hessian, is like the second derivative that allows optimization algorithms to actually know where to go. The problem with the Hessian is that it's on the order of R to the D cross D, right? And so these are huge. And so the problem is that trying to use a Hessian makes it use way too much memory. So looks like what they're doing is they're approximating the inverse Hessian by doing this. So it's a Hessian approximation. That's cool. Do you remember that? Man, I miss school sometimes. Okay, that was a little digression. Like, now you can see how my brain works when no one else is going. Okay, Adir, you need to pass in GPU equals 1 on your Lightning trainer. Thank you, Adir. Adir, that's cool. Do you know, if you know Lightning, PyTorch Lightning, you call me out. If I'm doing something wrong, you'd be like, no, that is wrong, Seth. You're doing it wrong. And then I'll be like, and then we'll fix it. All right, let's talk about data, because we need some data. So we did this. Let's go back here. So Lightning module, right? There's got to be a data thing here somewhere. Here, look at that. I knew it. There it is. Let's see what they got for us here. A data module is a shareable, reusable class that encapsulates all the steps needed to process data. That's what I want. Okay. So the data module encapsulates 5 steps involved in data processing. Download, tokenize, process. We already got that. We need to do this part. Clean and maybe save to disk. We don't need to do that. Load inside a data set. We definitely need to do that. Apply transforms, rotate. We definitely need to do that. And we need to wrap inside a data loader. Yeah. If you notice in PyTorch, let's have this go away. We have these data loader thingies. Let's have this go away. You can see here, like, I'm doing some data loading and some transformation. Notice for the training and the validation transformations are almost exactly the same. Oh, except here we do a resize and a center crop. Why do we, what? And here we only do a random resized crop. Oh, I see. This is probably why So this is probably why we're getting a discrepancy between the training accuracy and the validation accuracy. Remember we got some weird, here we go. Do you see how our accuracy between training and validation always varied for more than 10 points? My guess is maybe it has something to do with this. And I can see why we did this. These normalization numbers, by the way, I think I just stole from the PyTorch website, if I'm being honest. Random horizontal flip is awesome because this basically makes our data set bigger somehow. If we do it right. I don't know if I did it right. Those should be the same, right? So Kevin's like, those should be the same, right? The transforms between training and validation. The answer, it could be yes and it could be no, right? And the reason why is because, let's just say I wanted to invent more images. Like, so for example, if I'm doing a random horizontal transpose or random horizontal flip, basically taking a look at the data, let's go to some training data. So basically this image and then the horizontal flip would be counted as none, which now means I have, instead of 1 image to train, I have 2. Right? We don't want to do that during validation. This is my feeling. Right? So these random flips make it so that in theory I could augment my data. In theory, right? Random resized crop. Again, if it's random, then in theory, like, we might be pulling here, let's zoom. No, not that. Let's zoom it in here. We might be pulling random 224 by 224 here. We might be pulling random 224 by 224 here. We might be pulling this image right here. or this image right here. And so in theory, what we've done is we've made it so that out of one image, we got 1, 2, 3, 4, 5 images times 2 because you can horizontally flip. It's like, look, again, talking of underwear, if you run out, you can literally reuse underwear 4 times, right? Front to back, inside out. Multiply them, that's 4 times. Here's from Sharafuddin. Instead of copy pasting all coding into one programming, we will have a stepper wizards and pasting respective coding step. For beginners to learn. What do you think? Yeah, I mean, anything y'all want me to do, I'll do it. I'm literally just trying to make it work. But to me, like this all fits on one. This here thing all fits on one screen. And to me, this is way clearer than whatever I had before. This is super clear. You know? So the only thing I could do is literally like I could make this smaller, right? By putting that into the imports. But you can see like literally, I don't even need this. Literally, this is so easy to digest. This to me is absolutely glorious. So whatever they're doing. So Jonathan Tien, I remember the accuracy of Val normally lower than train accuracy. That is right. That's why usually like, and Johnny is saying the validation accuracy is usually lower and this is higher. And if the number is greater than ish, 5 to 6 to 7 to 10, then you've done something called overfitting. We haven't done that, right? So this is interesting to me. And it just may be a situation where like this accuracy is bad because of how we're doing the random crops and flips. And this one is more resilient to that. And there's also like only 10 of them, I think. How many of them are there? So let's go. Let's reveal in File Explorer. Okay, and let's go view. So here they are, right? You can see that I have 59 in the training, but in the validation, how many things are in there? Let's go properties here. 83 file. There's only 83 of them. That's not a lot. And it could be a situation related to that. Yeah, Kevin, look at Kevin. Like Kevin and I are like on point together. There just may not be enough data. And I think that's also what's going on to cause overfitting. Yep. Yes, sir. I think we are in agreement. Good questions here. All right. So let's go back over here. And now we are going to be, we don't need this. Now we're doing the data bits. So let's go over here back to this thing. Why do we already agreed that we got a data module. Okay, so here is a data module. Let's just do what we did before. Because we're cheaters. We're not cheaters. We're doing what they want us to do. Okay. So looks like we need, let me move this over here. We got this over here. For sure. Oh, let's do this here from typing optional. Okay, and then we don't need mnist. From torch.data. Is there data? Where is it? Sets. Here we go. I think we can use these, right? Where's the data loader? Here we go. We want data loader. And we also want these things. We don't need models because I'm guessing that it's in here where in the data that we do the transformations, right? So we got that. Okay. Okay. So the other thing that I'm struggling with is I've like forced, and I don't know if I like this, but I've forced there to be a training and a validation folder. I wonder Let me see here. Reveal and Explorer. Reveal and File Explorer. I wonder if we have a images folder. And what I'm going to do is I'm going to bring all the validation data into here, and then all of the training data into here. And let's see if there's a way in PyTorch to do random split. PyTorch random split. Yes. Oh, hey now. Okay. And here we go. Well, there you go. Well, shoot. Let's just do this. That way we can control, we can control it. So we're going to be a little bit more cleverer. Okay, I think we're ready. So we have the data dir. That's that. We have the batch size, right? I feel like maybe the transforms should be set up in the init, or maybe in the setup they should be set up. This is the part that's confusing. Okay, so let's go over. We definitely don't need. We don't need this. Let me go over. Oh, look, it was right there. Random split. Look at that. Okay. So let's go to, okay, I see how they're doing it. Okay. Cool. All right, so let's go over here and let's see how we're loading our data up. Cool. And this is gonna be good. So we're using the image folder data sets. And looks like we have to give it the transformations we want. Okay. So, what if we don't give it any transformations? Okay, so let's do the raw data set. Okay, cool. Okay, so what we'll do self dot raw data equals data sets dot image folder, right? And the image folder is also obviously going to be self dot data dir. Okay. So let's do this. Let's comment all this garbage out. And okay, so we don't need that. Cool. Okay, so we've got that. The other thing is we need to somehow get the number of classes too, right? So self.classes equals self.raw data.classes. No. Classes. There you go. So now we have the classes. So then this thing can give us the number of classes when we pass it into boom. So here's a question from Gerard Samuel. Is there any way to use Azure Q&A Maker in Unity game? Yeah, I don't see why not. I mean, it's just an API call. For inference, yeah, absolutely. Good question. Okay, so we've got this self.raw.classes, and now what we want to do is we want to have our transformations for training, because we're trying to keep everything the same. So train transforms, and then we'll have validation transforms. If some of y'all think this is a dumb idea, let me know, because okay. So there's our transforms. Shouldn't it be able to pick up the number of classes? Yes. So the question from Kevin is, shouldn't it be able to pick up the number of classes based on the folders? Yes. That's what this class does. And so notice when I do that, right? In the raw data, I have the classes and I have them here. I'm just basically putting it to this class. That way, when I instantiate, this is the Roshambo data module. Basically, I can just say data module.classes and pass that in to the model. So that it's just I could basically say Roshambo data module dot raw data dot classes, but I'm just trying to short circuit. Here's a question. Can we do an experiment? Let's apply those same random transformations on validation 2 to see if the metrics match after training. Good call. Let's do that. So let me do self here, self here. Let's do that. Let's do that experiment literally right now. So validation here. And let's go back over here and let's run it. Oh, I moved the file, remember? So cd old. Yeah, this might have a problem. But let's do this, Adir. Adir said, can we do an experiment? Let's apply those same random transforms on the validation to see if the metrics match after training. Let's do that. We'll do that on the once we get the data bits going. So I'll do that here. I'll do this here. Oops. So this is the setup for the transformations. And what I want is I want a train and a validation. So I think, let me see. So they have a train and a val. I'm not going to do test because I don't think I don't need to tear down anything. So we'll take that off. We'll take that off. Okay. Cool. Okay. Now we just need to build the random split thing. And where is the random split thing again? Torch.utils.data. Torch.utils.data random split. Torch.utils.data. Oh, look at that. Boop. Nice. So now what we're going to do is we're going to say, what did I call them over here? Let's see here. Val data set and train data set. So self.train data set, comma self.val data set equals random split of Kevin says there's a lightning module for the lightning data module too if you want. Yeah, that's what I'm doing. Like right here. I'm literally building I didn't import the thing. That's what I'm doing right now. If you're wondering. Just got to put that here. And I'm literally making a data module right now, Kevin. It's like Kevin and I, we're like brothers from another mother, misters from another sister. Yeah. Thanks, K-Dog. Can I call you K-Dog? Algum brasileiro. Eu posso falar português, mas somente pouquinho. Because really I speak Spanish and French, and Portuguese is like a drunk French person trying to speak Spanish. That was all culturally insensitive. Mas eu posso entender português se eu quero. Love Brazil, by the way. Such awesome people there. Random split. It looks like we need a data set. We need a data set. So again, that would be self.raw data. And looks like we need a split sequence of int. So let's do this. Let's do this. Let's put this down over here. And then let's do a split here. Train split float equals 0.8. And then we'll just do self.train. Oh, so you have a just like tweet at me, bud, and I'll look at it. Train split. But this is the example. Oh my goodness, someone's talking to me on Slack. What? Tell me. Oh, no, nobody. So what I'll do is I will say, okay, let's go to the random split 3-7. So I think what I'm going to do is I'll put the train split first. I think that's what I do here. So train. Okay, cool. So we'll do self.train split, and then we'll do 1 minus self.train split. But I mean, how do I give it the transforms though? Let's see. Okay, self dot. Oh no. Self dot train data set dot This is the problem. Like, how do I give it the transformation? Yeah, I think this is it right now. Kevin, I think I'm doing the same thing, right? I'm inheriting from this thing. So this is the challenge. Like, how do I give the data set the transforms? Oh, wait a minute. Is it the data set that gets a transform or the data loader? Yeah, it's the freaking So we've got to find a way to jeez. We've got to find a way to here, let's do this here so it's not so ugly. I wonder if I just use a single transform. Let's do this. Let's just use a single transform for now. This obby goes right here. Image folder and then comma transform equals self dot transform. Right. Hopefully I'm not yeah. Okay. So now this should be the thing. Okay. So this should do the right thing now, right? I think so. Because we're setting all the data sets up, right? Am I right? See, because oh, wait a minute. This is not going to work because they want the actual number. Okay, so we're going to have to do some maths. So let's just do some maths here because we need to give it the actual numbers. Looks like. So we want the train size to equal self dot. Oh, we're also going to need the length, and I don't want to calculate that more than once. Size equals length of self dot raw data. Fantastic. So self dot train split times size, and what we want to do is we want to do gotta do some mathies here, otherwise things are import math. Boop, 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 boop. We'll do math.floor, and then we'll do val size equals size minus train size. Okay, now we can say this, and then we can do this. Almost blew it up. Okay, there you go. Okay. There you go. That works. So random split. Yeah. See, there's a sequence of int, and that's what we wanted. And then it gets a subset of the random split. Okay, so those are ints. So now we're good. We don't need this. I don't think we need to do anything over here other than this. I think we're done. What? I think we're done. My face is too far away. Hold on. Someone's trying to tell me something. Here, let me go over here. Vanessa's back, so now we have to be everyone on your best behavior. Vanessa is back. Algum brasileiro? Muito bom. Okay. Okay, I think this is really it. I think this is it. Oh, I got your tweets, K-Dog. Yeah, I think this is it. It can't be this easy. Now I'm all nervous. We probably still have to do some stuff here. But like this is just pretty. All right, let's see if it works though. No, I might. You know how I got all excited about it, and I'm probably wrong here. So let's do this. Let's test it out, and let's okay. Let me do this. Let me make a file called main, and then do everything in there. New file, main.py. Kapow. From model import Roshambo model. Now, I reported this. I don't know if I'm doing this right, but look, if I do this, it like sees it and it's like, oh, that's great. But it doesn't run, and you'll see in a second. From data import Roshambo data module. And what we're going to do here, we're going to go over not to you here. Just so we can run it. Def main pass. Okay, here we go. Let's see if this is going to do it. Okay, fingers crossed. Let's go back to this. We did the data module. Everything is hunky-dory. Yes. Prepare data. Uses method to do things right to disk. We didn't need to do that. We did a setup. We did that. Train data to get the training data loader. Usually just wrap the data set in the setup. Yes. 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 Transfer batch to device. No, I want to just do the whatever. This is cool though that we can do this. Using a data module. Here we go. Oh my goodness. Did we do it? Roshambo model. Looks like we need to do the data module first. This thing, right? dm.setup, right? Because we need dm.classes for the model, which is Roshambo model. Also, we need to pass it the actual path to the dir. So data dir equals back data, and we called it images. Boom, data dir, right? This we're gonna leave just leave everything else. 32 batch size is too high, so we'll do 8 on the batch size, and we're good to go. So now for the Roshambo data model, we have the number of classes. So I guess classes equals the length of dm.classes, right? Because it's a number. And then what was the other thing we needed? Learning rate. Oh, yeah. Learning rate equals 0.01. What is this trainer stuff? Oh no. Okay. Now let's go figure out what this trainer business is. Okay. Step-by-step walkthrough. They'll have it in here for sure. Faux show. So there is the module. Size, training step. Yeah, we got that. We did that. Trainer. Here is this thing. So we need to trainer. Where is this coming from? Alt F8. No. Okay, so we got to find where this trainer is because it's just like a imports Where are you hiding, trainer? Where? Okay, so we got that. Oh my goodness. Like you would think that they would put the trainer somewhere where I could find it. I mean, am I right? Okay, come on. It comes from lightning. Yeah, I know it comes from lightning, Adir, but is it let's try. Let's just go with from PyTorch lightning import trainer. Oh, there it is. Adir, genius. I wonder if there's like some stuff we can pass in. Let's go to the definition. Oh, look at that. Kevin's like, derf. All right, there's got to be a way. Okay, GPUs. I have one. What do I just say? 0? Let's try that. Let's just try it. I mean, that's what we're here to do. We're here to try stuff, break stuff. Trainer GPUs. Is there a GPUs equal 1? Hopefully that works. All right, let's try it. We're going to go over here now. We're in the new one, and PyTorch or Python main. If this works, I'm going to retire. Oh yeah, I forgot about that. GPUs equals 1. Is it GPUs or GPU? So go to definition here. GPUs. Auto select GPUs equals false. Maybe I should set that to true. All right. By the way, I remember how I told you there's this issue. We need to fix that. I don't know why it does that. Okay. Okay, let's do it again. Here we go. You passed in val data loader, but you have no validation step. Skipping the validation loop. What? Things are happening. Am I using the GPU? Look at that. I wonder what the deal is with the validations. I wonder why it's not doing that. And also I'm not seeing the I'm seeing the loss not go down, but I mean I wonder how to print I wonder how we can print. So look, it worked. It's doing things, which is great. Because remember our goal was to run the training. So we're pretty good. It's pretty good. I mean, these two classes, let me split right here. Split right. And then let's do data over here. I already did that one. Train over here. No, that's not the one. Let's see. Let's go over here. Model. There you go. Oh, there's a C there. This looks much better than what we had before. Right? I think it looks better. So it's on Epoch 20, but I don't really have any sense about like I don't have a sense for. By the way, this is cool how it like outputs this. It's like, oh, it's a ResNet. Then some fully connected layers here. This is concerning. I have no validation step. Oh, it's here. Let's fix that. Okay, so let's Control C. Looks like we need a validation step, and I messed that up. But it ran. So that's the good bit. So let's go to the style guide here. Let's go down. Sorry, people. Sometimes the people tell me stuff, and I need to do what they say. So validation step. That's what we're missing. So let's go to the step-by-step walkthrough. Or was it that? What was this? No, it wasn't this one. It was the lightning module thing that was super helpful. We're missing the validation step. Let's see what the parameters. There's the training. Here it is. Okay. Okay, let's do this. Okay, so let's close this because I think that those things are good. So batch, no self.model. It's just, is it self? I think it's just self. F.cross entropy. It feels like the same thing, but we're logging the loss. I wonder if we can do some accuracy stuff. So val loss. Okay, so let's do this. Yeah, loss seems to be going down. So that was Adir. You're right. Loss is going down. Let's get the validation set, because now, Adir, we can actually test whether the validation and the training stuff is together now. So let's do some accuracy stuff here. So the way we did accuracy, we did batch level and epoch level accuracy. So let's just do batch level accuracy. Here it is. Here it is. Let's do this. So let's split this to the right. And let's just do some accuracy numbers. This looks all the same. So let's do like a static method, right? And then we'll say def compute. And then let's just do a double underscore compute. And what we want is we want the X and the Y, the X and the Y, right? I wonder if PyTorch is okay with this, because a computational graph would still work, especially if we were. Yeah, this should all work. So what we want to do is we want to say y hat equals self of x, right? Then we want to say the loss equals. So just basically these two things, right? Nice. Okay. Then let's compute the accuracy here. I feel like there's a better way. This feels weirdly weird to me. Let's do this. Import torch. Predictions would be y hat. Y. And then we want to do torch dot sum. Okay, and then what we want to do is we need to divide this by the length of x. No, this is right. This is right. This is right. I don't know why I did a loss divided by this. So what we'll do is we'll return the loss and the accuracy. And now what we can do is we can just say, we can take this out. We can take these two things out, right? And what I can do is I can just say return compute y. Or I can say loss accuracy equals self dot compute x y. Looks like there's a whole torch metrics module you can use. Yeah, I should totally look into that. But I promised myself, oh, you know what? I can't do this, right? Unless it's not a static method. I need to pass in self. Might as well just do the batch too, right? Batch. And then I can just say doop, 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 doop. Right? Oh, come on. Batch. Right, and you can say return loss. It looks like there's some logging going on here. Yeah. Let's let's see what happens if we just log this stuff. So self.log, log, and then we're going to say loss, comma, loss. And then we'll do self.log accuracy, ACC, and then ACC. Okay. Then what we can do is we can do all of this again on the validation. So let's say you don't have to return anything, but we'll say val loss and then val accuracy. Okay. Okay. Let's try this and let's see what happens. And again, we are 8 minutes out from the end of the show. And we might get it done. We might get it done. Okay. Crossing our fingers. Here we go. Here we go. Okay. So far, so good. Nice. Here we go. Uh-oh. The size of tensor A4 must match a non-singleton dimension. So where are we at? Trainer.fit all the way to model here. This is my accuracy bit. Oh man. I wonder. Let's try that. Because what it's saying is there's a mismatch with this and this, even though there shouldn't be, because we did that before. Let's try it again. We're going to get this in 7 minutes. Again. Okay. Oh, I'm an idiot. I know what I did wrong. So I need to actually do the predictions. The predictions are these ones. Okay. Torch.max, y hat. I get it. See, what's happening is you get a vector of size 4, but the y value is of size 1, right? And so we're getting double of everything, which is not right. Okay. Yeah, right. So here are the outputs of the model, right? We get the predictions, torch.max, and it returns a tuple or a tuple. We get the cost, between this and this. Then we get then I'm getting the predictions here. So this is for loss, and then this is for accuracy. Okay, and then that will do it. Okay, this should work. Apologies. Let's just get all this out of here. All right, here we go. Okay, so it looks like validation is happening, but I'm not seeing. How do we print stuff out? Look, maybe there's something in here. Name, value, logger. Bool equals true. On step, bool, none. On epoch. Oh, let's do this. On step equals true. And let's put it on the validation too. All right, here we go. Print something out for me. No, it's not. Huh. The loss is going down, though. On epoch. Oh, come on. Okay. The default behavior per hook is as follows. If true, logs at this step. Oh, progress bar. Let's put that in there. put that in there instead. Prog bar, prog bar, prog bar. Okay, you stop what you're doing right now. Yeah, look at Kevin. Look at him. We're like, here we go. This is going to do it. Oh, shoot. So I don't need to do loss during training. So let's take that out. I don't like warnings, okay? They make me nervous, but I think we're making progress. Here we go. This is the one. I feel it. Booyah! What it is. Wait, how am I getting 6.9 accuracy here? Oh, I need to divide by something. I feel like, yeah, I need to divide by the length of X. Oh, math. Always a cruel mistress. But yes, boom. That's right. Let's fix this one more time. And let's see if we can do it now. Here we go. Here we go. This is the one with 2 minutes to spare. Are we going to do it? Yes. I'm not seeing training accuracy, though. Oh, yeah, there it is. What? But this isn't over. Wait, this can't be right. Is this right? Well, it's doing it. Well, my friends, thank you. It's been wonderful being with you again during this episode of the AI Show. Next time, we're going to try to put this, save the model, and redo all the inference stuff again next time. By the way, thanks so much for coming, and we will see you next time.